Now, when we're talking about evaluating statistical claims, there are certain things to keep in mind. One, you want to make sure that you have a pretty good sample size here, which 500 is very good. It would only be questionable when it's maybe fewer than 10. I think that most statistics books will say you need at least 30 typically for it to be fairly accurate or potentially representative of the overall population in question. You also want to be really dialed in on what this sample demographic was. So notice these 500 participants are specifically of people with insomnia. So we could eliminate option A because it's saying it's likely to improve the sleep of anyone. Well, no, we don't necessarily know that because it was only based on people with insomnia. It may be good for anyone, but based on the actual sample, we only know that it helps with people with insomnia based on the experiment. For option B, we didn't really compare it with other treatments. We were just specifically focusing on the treatment versus people not receiving the treatment, not comparing it with other treatments. For option C, it says it's likely to improve the sleep of people with insomnia. Now, the results did indicate that these people who did get the treatment were able to sleep significantly better. And because of the fact that it was randomly assigned, there wasn't any kind of bias, it was a good sample size of 500 people, that's a pretty logical conclusion to make. It seems like that's a well done experiment, no red flags there. And so we're not going to say no conclusion's appropriate. Option C is an appropriate conclusion.